మీ నెట్తోనే తీసుకోండి అని చెప్తుంది.
Hello students, good morning. Good morning guys. Good morning Vagmi. Good morning Shubham. Yes, let the others join. Inform the others to join quickly. Yes, good morning Nana. Good morning Yogashri. Good morning Chaturpuja. Just a minute. Yes, good morning, students. So, I think you guys have attended in the evening session. I have briefly revised this, which we supposed to discuss in the previous session. Okay. Once again, I would like to go through briefly these points, the main points here. Okay, related to collisions, the basic part of the collisions. So first thing, what you need to have an idea about is what is a collision. What is a collision? So collision is nothing but an interaction in which exchange of momentum takes place. Exchange of collision is an interaction in which exchange of momentum takes place among the bodies which are participating in the collision. Is a collision is a, that interaction is called a collision. Okay, these collisions are classified into different types based on different parameters. First thing you can say, yes, ma'am. Sorry guys, there was some discussion with the principal madam. Right, very good morning, Very good morning, Raya. Who is this? Nandini Rajnikant. So is this guy, man? Hari Balaji. Good morning, Nana. Good morning. Right. So, one second, guys. One second. Students, sorry for the inconvenience. Right. Yes, everyone. Welcome back. I hope you're getting my voice clearly. Right. So, let us see once again briefly about these points. Yeah. So, the collisions are classified into different types based on different parameters. The types of collisions. So, write down these points quickly. Okay. So the collisions are classified first based on direction of motion of bodies, and the collisions can also be classified based on conservation of kinetic energy that we'll see later. First write down the subheading types of collisions under that based on direction of motion of bodies. Okay, so based on direction of motion of bodies, the collisions are classified into two types, namely one dimensional collision and oblique collision. One dimensional collision is also called as head on collision. Oblique collisions may be either two dimensional or three dimensional. Let us see one by one little briefly. So one dimensional collision or head-on collision, what is this? So write down like first kind of a definition, then you can understand clearly what is what. One dimensional collision. So write down here the collision in which here write down the collision in which the bodies move along the same straight line. The bodies move along the same straight line. Okay, the collision in which the bodies move along the same yeah, the collision in which the bodies move along the same straight line before and after collision. Before and after collision before and after collision is called a one dimensional or head on collision. So like this you can draw this diagram. So if two bodies m1 and m2 are moving with velocities u1 u2, so that if if u1 is greater than u2, if if u1 is greater than u2, then u1 will be moving little faster than u2, and I mean m1 will be moving little faster than m2, and it goes after some time hits the m2 body. So they will be in contact, physical contact for some time, very short interval of time. After that they will move apart and they will be moving with different velocities. So after collision, the velocities of the bodies are said to be v1 and v2. The velocities of the bodies are said to be v1 and v2. Okay, and here if you observe the line drawn from the line passing through centers of the bodies. If you draw a line passing through the centers of the bodies before collision, this is the line along which the bodies are moving. After collision also along the same line they are moving. Such kind of collision is called as one dimensional or head-on collision. One dimensional or head-on collision. So another example this one, if you see in alpha scattering experiment, so a positively charged nucleus will be situated at some point, and another positively charged alpha particle, if it approaches along the line passing through the centers of these two, then it comes and stops somewhere due to strong repulsive force between these two and retraces back along the same line. So here you can say they are colliding with each other. Due to that, it stops and move with a different velocity in opposite direction but along the same line. Before stopping, we can call it as a collision. Before collision, it is moving along this line. After a collision, it is moving along the same line but in opposite direction. So here, if you observe carefully, an interaction is taking place. An interaction, collision is nothing but an interaction, but without any physical contact between alpha particle and the nucleus. So we can say that collision to takes place, two bodies need not to be in physical contact. That is what we can conclude. So we can write down this note. During collision, the bodies may or may not be in physical contact. May or may not be in physical contact. Or for a collision to take place, bodies need not to be in physical contact. That is one of the very important point you have to consider. So you can also recollect few other examples like collision between charged particles. If you have two charges, positive charges plus q1 and plus q2, or minus q1 minus q2, if you bring two charges closer, they, because of repulsion, they will move away from one another. So that means we can call this kind of interaction also a collision. So if you bring two magnets, one exert another force, the force on the another, if you bring the like poles of two magnets towards each other, they repel each other. That can also be considered as a collision. So for a collision to take place, two bodies need not to be in physical contact. That is what we can understand. Okay, so note down this point. Right. Copied. Next, let us see what is oblique collision. What is oblique collision? Write down subheading oblique collision. Oblique collision, the collision in which the colliding bodies are not confined. The collision in which the colliding bodies are not confined to move along the same straight line. The collision in which the colliding bodies are not confined to move along same straight line before and after collision is called an oblique collision. It can be either two-dimensional or three-dimensional. Two-dimensional or three-dimensional. Write down this. I try to draw this diagram so that will give little more clarity about the meaning of oblique collision. What is that? So here two bodies m1 and m2 are moving with velocities u1 and u2, so that here if u1 is greater than u2, if u1 is greater than u2, after some time these two bodies will collide. This goes and collide with this, so they will be in physical contact momentarily for a short interval of time, then they will move away. And how if m1 is moving with some velocity v1 in this direction, m2 is moving with some velocity v2 in this direction, that means after collision, this is before collision, they are moving along a line. After collision, if they are moving in a different directions, such kind of collision will be called as oblique collision. Oblique collision. Okay, this are briefly about one dimensional and oblique collisions. The next one is we have discussed that collisions can be classified based on direction of motion, first parameter. Second parameter, we can classify collisions based on another parameter, that is based on conservation of energy, especially kinetic energy. So based on conservation of kinetic energy also we can classify collisions. But into how many types? Let us see that. So write down next subheading based on conservation of energy. Based on conservation of energy. Under that, write down collisions are classified into again two types. Viz, V-I-Z, Viz means namely number one, elastic collision, and number two, inelastic collision. Number one, elastic collision, and number two, inelastic collision. Note down, write down this everyone. Here, Here, elastic collision. So what is elastic collision? Write down briefly. I think some of you have attended yesterday's study hour session. Those who have might be copied. Some other students are there. So try to copy this briefly and quickly. Yeah. So what is elastic collision? Write down under this. The collision in which both momentum and kinetic energy are conserved. The collision in which both momentum and kinetic energy are conserved is called is called is called an elastic collision. An elastic collision. So examples. Write down under this itself examples for elastic collision, where you can observe this kind of collisions. So just now we have discussed about what you call alpha scattering experiment, right? This alpha scattering experiment collision can be treated as elastic collision. So write down the first one: collision of alpha particle with nucleus. Collision of alpha particle with nucleus. So in that collision, both momentum and kinetic energy will conserve. Will conserve. Next, another example you can say the collision between any two atomic particles or subatomic particles. Subatomic particles means any two charges, like charges or unlike charges. Okay, especially if you consider unlike charges, you can say interaction between any two unlike charges, positive positive or negative negative charges, can be treated as an elastic collision. And then write down, and you can also say the collision between two smooth billiard balls can also be treated as an elastic collision. Can also be treated as an elastic collision. Okay, right. So next, write down the subheading: in elastic inelastic collision. Write down next subheading: inelastic collision. So what is inelastic collision? The collision, write down the collision in which only momentum P is conserved. The collision in which only momentum P is conserved but not kinetic energy. But not kinetic energy. The collision in which only momentum P is conserved but not kinetic energy is called an inelastic collision. Is called an inelastic collision. Okay. So example, just you can write just in general, the collision between any two vehicles. We might see in roads some accidents. You might not see the live accident. Okay, in movies you might have see the what do you call accident scenes. If you imagine that, so initially before the accident or collision, the two bodies will be having different masses and they will be moving in some velocities. Okay, and so they will be having some energy. So during collision, so you may hear a big sound, and also some heat and energy also will heat energy also will be produced. So the kinetic energy whatever the bodies or vehicles are possessing before collision, a part of it will be converted into sound energy and heat energy. So after collision, initial kinetic energy will not be equal to final kinetic energy. So we can say that energy will not conserve, energy will not remain same. So such kind of collisions are called as inelastic collisions. Inelastic collisions. So in inelastic collisions, energy will not conserve. Initial kinetic energy will not be equal to final kinetic energy. Such kind of collisions are called inelastic collisions. But momentum will conserve. Momentum will conserve. Okay, right? This kind of collisions are called inelastic collision. So here we come across another kind of collision. In some books you may find this as another type, as actually a third type, but actually it is one of the special case of the collisions. So that is perfectly inelastic collision. Perfectly inelastic collision. Write down this, everyone. Write down. Perfectly inelastic collision. What is perfectly inelastic collision? We have understood what is elastic collision. What is inelastic collision? In elastic collision, both momentum and kinetic energy conserves. In inelastic collision, only momentum conserves but not kinetic energy. So in what is perfectly inelastic collision? perfectly inelastic. Here the term inelastic is there. Inelastic is there means obviously only momentum conserves but not kinetic energy. That condition should be applicable for inelastic. Then what is perfectly? So additional condition will come. Another some special condition will come for this perfectly inelastic. What is that? So to understand this, let us see this diagram. Then we can give what you call a definition kind of sentence to understand. Then we can go ahead. Okay. What is perfectly inelastic collision? So we have better write down here the collision in which the two bodies stick together and move with common velocity after collision is called perfectly inelastic collision. I will dictate here, write down once again. What is perfectly inelastic collision? The the collision in which the collision in which two bodies the collision in which two bodies stick together stick the collision in which two bodies stick together the collision in which two bodies stick together and and move with move with common velocity. The collision in which two bodies stick together and move with common velocity after collision is called perfectly inelastic collision. Is called a perfectly inelastic collision. Okay, so you can draw this diagram. What is that? You have two bodies m1 and m2. They are moving with velocities u1, u2, and some cases m1, m2 may be at rest also. Those are the special cases we'll see later. So here again, if u1 is greater than u2, if u2 greater than u1, they will not never collide. This will move further and further. Right? They will not never collide. If u1 is greater than u2, then only they will collide after some time. And after collision, this is before collision, during collision, and after collision, these two bodies will stick together. The two bodies will stick together and they move with the same velocity, with common velocity. With common velocity. Such kind of collision is called perfectly inelastic collision. Such kind of collision is called perfectly inelastic collision. Okay, write down this everyone. Right, then write down like an example. What is write down an example. A bullet fired into a wooden block and the bullet remains embedded in it is an example for perfectly inelastic collision. Okay. And if you take mud and if you throw onto the wall, you can write that also another example. Okay, a mud thrown onto a wall stick if mud thrown onto a wall, it stick to the wall. This also an example for perfectly inelastic collision. It will both will stick but they will not move, it will stick. Okay. Or if you can say a vehicle is moving and if you throw some mud on the vehicle, so after collision, the mud will stick to the vehicle and both of this will move with same velocity. With same velocity of the vehicle or whatever it is, with same velocity, with common velocity. This kind of examples are called, you can say this kind of scenarios are called perfectly inelastic collisions. Okay, so here to understand this concept of collisions little deeply, you need to have an idea about one term or you can say two terms called those are nothing but line of impact and the line of motion. Line of impact and line of motion. So based on these parameters also we can classify the collisions actually. Based on line of impact and line of motion, we can classify the collisions. So here, how can you classify? Just I will give you an idea. Then you can you can write the definition of what is line of impact. So if two bodies move, or you can say if the two bodies possess same line of impact and the line of motion before and after collision, such kind of collision can be called as can be called as one-dimensional collision. So then, what is the meaning of line of motion and line of impact? Let us see. Line of motion. So it is nothing but the line or a path, a line or a path along which the bodies are moving, or the line drawn passing through the centers of the bodies. It can be called as line of motion. Okay, the path along which they are moving is called line of motion. So here, but line of impact, what is line of impact? If this is first body m1, this is second body m1, if they're moving with velocities u1, u2, so that if u1 is greater than u2, if u1 is greater than u2, after some time they will collide. During collision, this is before collision, this is during collision, this is after collision, this is during collision. During collision. During collision, these two bodies will come into contact momentarily for a very short interval of time. For a very short interval of time. During that time interval, the surfaces of these two bodies will be in contact. If you consider this body before collision, at this point, if you want to draw a normal, normal is nothing but a line perpendicular to the surface. Here, if you want to draw, this will be a normal to the surface at this point, a line perpendicular to the surface at that point. So here, at the point of contact during collision, if you want to draw a normal to both the surfaces at the point of contact, okay, then this will be the normal for this surface, the same thing will be the normal for this surface also. So both surfaces will have a common normal is same for both surface of the first body and surface of second body. Are you following, everyone? So this line or this normal, a common normal, is called line of impact. So write down here as a definition, write down this, everyone. The line passing through the common normal, to the surfaces in contact during collision is called line of impact. Write down this, everyone. Is called line of impact. Is called line of impact. So now again, if you recollect back the classification of collisions based on this line of impact and line of motion, if line of impact and line of motion both coincides for a collision, that kind of collision will be called as one-dimensional collision. You can say this is actually a 1D collision or one-dimensional collision. Whereas, just a second, guys. Right, guys. You see? Whereas, so if the line of impact and line of motion are same, such kind of collision will be called as one-dimensional collision. But in some cases, line of impact and line of motion are not same. Such kind of collision we can call it as an oblique collision. Okay, right. See here. So in this case, if a body of mass m1 is moving with velocity u1 in this direction, a body of mass m2 is moving with velocity u2 in this direction, now after some time they touch each other, means they collide both means same here. So they collide each other, so that at the point of contact during collision, normal to the surface of the first body is this one, normal to the surface of the second body is this one, so both are having common normal. This is a common normal. So the common normal to the surfaces in contact during collision is called line of impact. So this is line of impact. What is line of motion? Even after collision, see if first one is moving with some different, they collide and they will be moving in different directions. Initially, they are moving in different directions. So lines of motion are different before collision. Even after collision also they will move in different directions. So here line of impact and line of motion are not same. They are not same. Such kind of collision will be called as oblique collision. Write down this here, everyone, just to understand how to distinguish between line of impact and line of motion. Line of motion for the first body is this. Line of motion for second body is this. This is the line of motion. Okay, so they are not same in this case. In case of what you call oblique collision, right? Similarly, in this case, if you have an inclined object, I mean a wedge shaped, and if it is having some mass, and if another mass, if it is having some mass m1, another small body of mass m2 is falling vertically down. So line of motion for the vertically falling body is this, downwards. But when they come into contact during collision, a common normal to the surfaces in contact can be drawn like this. They are not same. So this can also be considered as an oblique collision. Got it? These are briefly about different kinds of collisions and what is line of impact and line of motion. Now let us see one-dimensional elastic collision. Very important point. Very important part, guys. This one-dimensional elastic collision. Under this, the example which we have considered earlier, the same thing we have to consider here also. So write down this. Write down. So subheading one-dimensional elastic collision. Under this, you can write like one sentence, a descriptive point. When two particles or bodies of masses m1 and m2 are moving along the line joining their centers, they're moving along the line. The line is passing through the centers of the bodies. Okay, so along a straight line, provided with some velocities u1 and u2. Provided if u1 is greater than u2, something like this. If you have two bodies, m1, or you can also just take like this. If this is a body of mass m1, there is another body of mass m2, right? They're moving along a line. They're moving along a line. That line joins the centers of the two bodies. This line joins the centers of the two bodies. So this is before collision. Before collision, they are moving along this line, joining the centers of the two bodies with velocities u1 and u2. Provided u1 is greater than u2. u1 is greater than u2. If u1 is greater than u2, after some time, they come into contact and they will collide. They will come into contact and they will collide. m1 and m2. This is m1. This is m2. They will collide for a short interval of time, for a short span of time. Then they will move away and they are moving with velocities, different velocities. The first body m1 is moving with velocity v1 and second body m2 is moving with velocity v2. This is after collision. Now, as it is a one-dimensional elastic collision, we are considering that one-dimensional elastic collision. As they are moving along same line before and after collisions, so we can call this as one-dimensional collision. So, but this one-dimensional collision, to say whether it is elastic or inelastic, we have to follow the definitions according to the definition of elastic collision. What is elastic collision? Try to recollect back, everyone. A collision in which both momentum and kinetic energy are conserved is called elastic collision. So here in this one-dimensional collision, to be elastic, this should satisfy those two conditions: conservation of momentum and conservation of energy. Okay, so here from conservation of momentum, you can say from conservation of momentum. So total momentum of the system, we have to consider here two bodies constitute a system, the system. Okay, so according to conservation of momentum, total initial momentum pi before collision should be equal to total final momentum of the system after collision. After collision. So total initial momentum is nothing but momentum of the first body. System consists of two bodies. Momentum of the first body m1 u1 plus momentum of the second body is m2 u2. This gives the total initial momentum of the system before collision. And after collision, mass will not change. m1 and m2s will remain same, but velocities have changed to v1 v2. So momentum of the first body becomes m1 v1. Momentum of the second body becomes plus m2 v2. So total momentum of the system of two bodies after collision is the sum of these two. So before collision, sum of these two will give the total initial momentum. So these two will conserve. So here, if you right, okay, here you can you can bring m1 if you want to bring m1 term common, and this if you bring this here, and you can write m1 into u1 minus v1, and if you bring this m2 here, and you can write m2 into v2 minus u2 minus u2. Okay, and just while working out even with the numericals, this kind of simplifications will be very important and will be more useful. Now let us consider this is first equation. Now from conservation of kinetic energy, you can say from, as it is a elastic collision we are considering, from conservation of kinetic energy, you can say the total kinetic energy initial, or the initial kinetic energy of the system should be equal to the total final kinetic energy. Total final kinetic energy. So kinetic energy of the system before collision is nothing but kinetic energy of the first body plus kinetic energy of the second body. So you can write this as half m1 u1 square plus half m2 u2 square gives the total kinetic energy of the system before collision. This should be equal to total kinetic energy after collision, that is half m1 v1 square plus half m2 v2 square. This gives the total kinetic energy after collision. Okay, let us consider this is second equation. Of course here you can cancel half in every term, and again and simplifying these two equations, we can will get one relation. Actually, if you bring m1 term here also, m1 terms, if you bring it here, if you bring m1 here, half you can cancel everywhere. u1 square minus v1 square will get here. If you bring this m2 terms here, m2 into v2 square minus u2 square will get. And this if you take this in terms of a square minus b square form, and a plus b into a minus b form, if you take and if you simplify, you'll get a final relation. That simplification I am not doing step by step. The final relation I am giving on solving 1 and 2, or you can say from 1 and 2 we will get a relation that gives you u1 minus u2 is equal to you can say v2 minus v1. This, let us consider this equation is the third equation. And here by substituting this from this relation, by substituting either u1 or u2 in equation 1, you will get so one of the parameters like velocities after collision. So we make use of these three equations 1, 2 and 3 to calculate the final velocity of the bodies after collision. So here again, just I would like to say that without doing step-by-step calculations, I would like to give you the expressions for final velocities. And before that, just you have to understand what this relations gives. So this u1 minus u2 gives the relative velocity of approach. This we can call this term as relative velocity of approach, and this v2 minus v1 can be called as relative velocity of separation. So actually the ratio between relative velocity of separation to relative velocity of approach will be given a special name called as coefficient of restitution. It is denoted by small e, that we will see later in the upcoming class, in the next class. So here I write down one subheading. From there onwards we'll continue in the next class. As time up, I'm winding the session now. Write down a subheading, velocities after collision. Velocities after collision. As we have missed the yesterday's session, we are a little lagging, guys. So in today's study hour time, I would like to take one extra class. So we have to finish this today itself. We have to finish this what is that concept of velocities, how to find the velocities after collision, and some special cases and some numericals also we have to cover today itself, guys. Try to attend the session without fail today evening study hours. Okay, take care everyone.